time variant and time invariant system. So we can say a system is said to be time invariant if the output input characteristics do not change with time. So here we can see that there is a continuous time input, that is xt. It's a continuous time input and you are applying to a continuous time system and you are getting such kind of response. So yt is the output for this given input to a particular continuous time system, and when you are delaying this input with t step, so that means the signal is started with t delay, and you are applying to this system and you are getting such kind of response. The shape is same but the output also shifted up to t step and you are getting such kind of output. So let's find out whether the system is time invariant or time variant. So here is the equation where we can see y t minus capital T equal to t of x of t minus t. So what it means? It means you are getting some output yt when you are applying a input xt. So if you delay the system with capital T time, then it is become y t minus capital T. So that is the thing, y t minus capital T is the output delayed with capital T step. So it's just started from here. So it's like this. So this output is delayed with capital T time. And what it means? It means it is the input of a particular system. So input is delayed with T step. So this is the input. This is the input and this is the output. So we just denoted these things. T of x t minus capital T. That means y t minus t. Okay, so this is y t minus t. So if those things are same, then the system is time invariant. So that means when you are applying some input and you are getting some output and you are delayed this output with some time interval, say capital T, and when you are delete the input with this time interval, say capital T, and you are getting some output and those things are same, then the system is time invariant, otherwise time variant. So it is same for the discrete time also, where xn and it will be yn and it will be x of n minus a capital N, and that is n minus a capital N, and it will be changing same in similar way. So let's see some example uh, of time variant and time invariant system. So here are some examples. See. So suppose the example one. So this is the equation whether the system is time variant or time invariant. So here all coefficient are just constant. There is no t, that means no time is involved with the coefficient, so that is the time invariant system. We can say the system is time invariant. It will not vary with time, but here you can see those things. It is the this is a this coefficient is a function of time, so it is varying with time. So this is a time variant system, time varying system. So as I told you, if this doesn't obey these things, so this is a time invariant system or time variant system. So let's see some example, some more examples. So here is an example. So let's discuss about this example. Yt equal to t of xt. So this is the system equation. You have to find out whether the system is time invariant or time variant, say yt is output equal to t of xt. We all know that output is an operation on input, that is txt given here. So y of t comma t, that means t of xt minus t. That means you are applying the input with t delay, x of t minus t. So you just follow this equation. You are applying the input with t delay, that means t into x of t minus capital T. T minus capital T. And here output is delayed by capital T. The next thing was output is delayed by capital T. So that is the output. If it's delayed by capital T, where there is T, you have to replace T minus capital T. So T minus capital T, x of T minus capital T. So that is the things. So if this one, that means if this and this are same, then it's a time invariant system, and both are not equal, then it's a time variant system. So in this case those are not equal, so it's a time variant. Okay, so again there is an example. So let's see the example. Here is the signal. So here in similar way yt equal to t of xt, these things, and y of t minus t comma capital T, that means you are applying the input with T delay, capital T delay, then in xt you are just putting x of t minus t. Okay, and if you delay the uh, output with capital T step, then where there is T, you have to just replace the T with T minus capital T. So here will be x of T minus capital T cos 50 pi T minus capital T when you are finding out that y of T minus capital T. So both will not be same. So this is also a time varying system. Okay, let's see what they have done. So this is also a time variant system, as I told you. So there is another example that is also continuous type of signal, that is a time variant. Uh, so in similar way they just find out. This is also an important problem. You can see that. So yt equal to x of minus t. So here also yt equal to x of minus t. When you are finding out that y of t comma capital T, that means you are applying the input with t delay. So that will be the thing, x of minus t minus capital T, and when you are delaying the output with t step, then you just replace with that y of t minus capital T equal to x of minus t minus of t minus capital T. So this becomes this. So those are not equal. So that's a time variance system. So there are some example also. Let's see some discrete system. So here is a discrete system, yn equal to x of 2n. So yn equal to x of 2n is the system equation. So yn equal to t of xn, that is x of 2n. And when you are shifted the input and you are applying to the system, then it's become x of 2n minus k. And here also y of n minus k. You are delaying the output. So you are delaying the output means if you are delaying the output with k step, y of n minus k, it's become 2 of in place of n you are just applying n minus k like this. So it's 2n minus 2k, both are not same, so it's a time variant. And there is also a system. Here also you can see this is the system equation. In similar way, when you are finding out this y of n comma k, it's become this, and when you are finding out the delayed output with k step, it's become this. This is not equal, so it's a time variant. So, and here is also a problem. Here you can say this is also time variant. So thank you for watching my video. If you find out the video is helpful for you, then you can share this video with others and you can subscribe my YouTube channel. Thank you.